Hello and welcome to my ENGG104 video task on series and parallel circuits in AC. AC stands for alternating current. When AC is the source of a circuit, the root mean squared value is used as the source voltage as a representative value of the power being provided to the circuit. Impedance Z is a complex quantity which can be related to resistors, inductors, and capacitors in both series and parallel, as seen by these equations. Due to its complex nature, an understanding of complex numbers is required for AC circuit analysis. There are two forms for complex numbers, and you need to know how to convert between the two, either using the complex mode in a calculator or Pythagoras' theorem. To analyze a series AC circuit, 3 steps are involved. First, using equations from the previous slides, find each component's impedance and then add them together for the total impedance. Step 2 is to plug in the known AC RMS voltage and the total impedance into Ohm's law as seen here. This gives the total current in the circuit. From this, Ohm's law can be used with individual impedances to calculate voltage drops across components. To analyze parallel circuits, similar steps are used. However, in parallel, impedance is combined as 1 over the addition of 1 over each component's impedance, as outlined by these equations. Following this, a total current can be found like in a series circuit. However, for step 3, branch currents are determined rather than voltage, as voltage is constant between branches. Now for a worked example. Using this circuit, we will find the total impedance, total current, and the current through both branches. First, we'll use the following two equations to find the XL and XC for the inductor and capacitor respectively, subbing in the values from the diagram. These reactance values can now be converted to impedance as seen here, where R and L reactances are added as they are in series. To combine the two parallel branches, the following formula is used. However, when finding the reciprocal, polar form must be used, and to add impedances, rectangular form must be used. This means a number of conversions between the forms must be done. However, through multiple conversions, the total impedance is found as 68.5 ohms with an angle of negative 63.5 degrees. This finishes part 1. Taking this total impedance and the voltage of the source and putting it into Ohm's law as seen here, a total current can then be found for part 2. For the RL branch, the impedance is converted first to polar form before being put into the same Ohm's law equation. And the same for the capacitor, where it's first converted to polar form and then put into the Ohm's law equation. And we're done. This is the final analysis for the circuit. For AC analysis, it is important to know your equations and understand conversions between rectangular and polar forms for a successful answer. Thank you for watching.